We've tried to run a program that didn't run. What was the point of that? I don't know. Why don't we actually make this thing run? So what we need is a secret key that kind of unlocks your program, and this is referred to as the magic number by many in the assembly world here, because without it your processor will never be able to run anything. It needs this little number in there to unlock it all. Okay, and this is kind of clever. I'm going to do this in binary because I just thought this was kind of funny. Of all the numbers they chose to make all of this work, here we go. It is 1010 1010. Okay, there's your first 8 bits, and then we're going to go 0101 0101. There. Okay, that's the key that unlocks it all, and it's in binary, so I'm going to signify that with a B. Again, that could be capital B, you know, whatever. B for binary, and there. I've just declared the magic number. Woohoo! We could actually go look at that real quick because it won't take very long. Just to go back to NASM, recompile, and back to GHEX and have a peek at it there. So basically the magic number is not in there because why isn't it in there? What did I do? GHEX o2.bin. I saved. What did I NASM? 0220. I see. Guess what? I made another 20. No, thank you. Let's get rid of you. And let's just do this right, shall we? Here. Okay, so I gotta get out GHEX to get back to the command line. Oh boy, here we go. Let's NASM it, but not as 20. So here we go. I'm gonna back up to the number right before. Hit the backspace key, and then I'm going to go 1 over the right and hit the 2. There! There, I have corrected it and made the o2.bin file that I was looking for in GHEX. There! The missing magic numbers. 55AA. Or actually, it's AA55 because we're dealing in little endian. Oh, if your head isn't spinning already. But yes, it's 55AA55. Okay, in binary there. Let's see, it would be it would be 1010101010 followed by 0101010101. Okay, the magic number. Okay, now the problem with that is. You not only need to input the magic number, it needs to be at a specific location. Okay, and where this needs to be, well, okay, your whole file needs to be 512 bytes in length, and so far we have 1, 2, 3, 4, 5, 6, 7 bytes happening here. Okay, and so that means that we have a bunch of empty space. And this here needs to be at the very end of those 512 bytes. This is the last 2 things in the list, right? So essentially, to get this in the location where it needs to be, we have to fill in with a bunch of zeros. And like a quickie way to do that, like now see, what I could do, we know how to make a data byte 0 like that, right? And I'm just gonna hit save, head back on over here, NASM it, and GHEX it. There, we've added a 0 in there now. Okay, so we need to be like what do we got? 8 now, and we need like 512. That's a lot of zeros, you know. So like instead of just going in here and going db0, 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 no. Anytime you do anything repetitive in computing, there's probably a way to let the computer do it for you. And in this case, the way we're going to do that is by calling times. Right here, times. And then I can specify a number of times. Like, it's like, it would be 8 from 512. You know, so I could manually put that in there. You know, 8 from 512 would be 504. like, right? And it'll repeat this enough times. Hopefully, if I got that right. Let's see if this happens. If I got it, hit the nail on the head or not. There's all my numbers, and all that hopefully is in the right position. Let's see if we can run the sucker. Here we go, by going over to Qemu now. Where's that Qemu command? It's way back there. I've done a lot of things since then. O2, good to go. And no, I did not. I did not. No bootable device. Okay, because why? I need the exact correct number of dBs in here. What did I say? 8 minus, oh wait, okay, so now I'm going to go with 506. But okay, so rather than play some guessing games here, there is actually a shortcut, and why don't I just get to the point instead of beating around the bush. So we know that this bit takes up the last 2 bytes of our formula. Okay, and so that means I can go 510 in here, 510, and then I'm going to go subtract some other bits up in here, whatever that may be, and the amount of code I have here may change. So we have a clever little equation that kind of does this for us. Minus, and what's inside the parentheses is dollar minus dollar. There we go. So this should hopefully work. Let me just cross my fingers here. I need to close Qemu to get me back to the command line over here, I believe. And actually, yeah, if you sometimes, gosh, if you try to go here and not to Qemu, it could kind of lock up everything, and now you can't do nothing. So you definitely have to close Qemu. Back to here, we shall just compile our new program real quick. I'm not going to look at it in ghex. I'm just going to go straight to Qemu, and there I have printed the number 1 to the screen. Which right here, you recall, was 31 in hexadecimal, or the number 49 in decimal. 1 starts at 49 for some godforsaken reason in computing. Okay, I've successfully compiled without having to do the math. I don't need to go too deeply into what this does. I will cover that when I cross that bridge. It's just kind of it's pretty straightforward. There you go, dollars minus dollars, right? For every dollar you make, you end up $2 in the hole, right? There, pretty simple. Okay, we have successfully actually compiled our first running program as if we had just booted a computer off of it. This is it, a minimal deluxe treatment program that prints something to the screen. Voila, written in assembly language and running under a virtual machine. It's called Qemu. There you go.